We've been talking about, and I admit mostly in terms of the United States, but I gather it applies elsewhere, as to how we can introduce diversity, particularly in the science area, the STEM area, where there's so much pressure to learn the subject and so on. And we talked a little bit in my session on Monday and a little bit elsewhere about how one might do it, but it seems that it isn't being done very well at the undergraduate level. And there are some other reasons for thinking that maybe something accompanying a graduate degree might be a good idea. I have way too many slides and too much on them, so I'm going to talk around them, and I will be happy to send the slides to anybody who would like, so you can read all of the bloom in detail. All right? So what we're going to talk about was based on an Nsf Grant Proposal. In fact, 2 Nsf proposals. The first one was funded and gave rise to these ideas. The second was not funded, partly because there are people who resist interdisciplinary programs and the idea that students from other disciplines can take graduate work in a certain discipline, particularly in STEM. So we'd like to tell you this is a great idea, and I say we because I have a huge number of collaborators I will thank later, and some collaborators I didn't have room to thank. And we're not trying to replace STEM. We're not trying to say that you shouldn't get a full technical education. I don't think anyone is saying that. Professor Kaios, with his discipline feeds interdiscipline, is very insistent on this. But we are saying first that you need to complement these skills, you need to get an interdisciplinary perspective, and you need to take a long-term perspective on your studies and your career. So I'm going to go through assumptions, I'm going to go through structure of the program, at least very quickly. I'm going to look at how it would fit. This is a certificate program in transitioning toward a master's degree. I'm going to look at what the benefits are for the stakeholders, and I'm going to look at what I haven't done. My emphasis is primarily on preparing people for master's degrees in computer science, data science, applied mathematics. But I think there are lessons for a lot broader fields, including outside of STEM in the social sciences, in perhaps some areas of communication, certainly nursing, and you can go on and on. Any lessons anyone else in any other field wants to take from this, feel free. Right, I'm happy to give away these ideas. If you want to write a paper about it next year, I'll review it and say it's a good one, okay? So first assumption is on computing and data science careers. And as we know, there's a huge market. It will continue to grow. There are some entry-level, low-knowledge jobs, but those are being outsourced to other countries, to other areas, to graduates of coding academies. As somebody said, why should I pay a software engineer $120,000 to do low-level stuff when I can pay somebody in Brazil $18 an hour or a coding academy graduate $50,000 a year to do the same work? So the low-level jobs with relatively high technical skills but low other skills will be more treadmill than career track. And on the other hand, at the other end, the number of high-level jobs is quickly outpacing the number of highly prepared graduates. And I think there are an awful lot of people here who would agree with that. And something else I keep hearing, I've heard at this conference several times already, not just from the advocates, but from others, that the high-knowledge, high-skilled jobs demand more than just technical skills. You cannot be an expert coder and expect to function just on that basis. Second assumption, most Big projects are going to involve teams. They're going to involve entire enterprises. They're going to benefit from a diversity in academic background, from cultures, interests, gender, disability even. Often a certain different way of perceiving the world leads to insights, as we heard yesterday from Professor Self. Happy to acknowledge everybody who's helped me. Right. So teams in large projects will benefit from role-based shared leadership. Every team at every moment will have a leader, possibly a documenter, some experts, and some collaborators. And those roles will vary depending on what you're doing. And enterprises will benefit from interdisciplinary as well as intercorporate ventures. Okay? And international projects certainly benefit from diversity. If you think you can set up in the United States entirely with native-born people, unless you're very lucky, and try to deal with a consortium that is in China and Saudi Arabia and Brazil and Germany and South Asia and Australia, you've got a big lesson coming. Third assumption, interdisciplinarity again. All of these STEM fields and a lot of other fields, every field interacts with technology. I don't care what it is. Art, you need to know technology now. Theater, you need to know technology. Sociology, you need to know technology. Right? English, I've been working a little bit informally, and some of my colleagues a little more formally with some of the digital humanities work at Seton Hall. Okay. Most interact non-trivially in more formal ways with computer science, mathematics, and/or the sciences. Almost any career will benefit. The more you know, more technical stuff you know, the more flexible you will be in looking for jobs. Doesn't mean that's the only stuff you need to know by a long shot. The more flexible you will be in lifelong learning, the more flexible you'll be in reading the newspaper and participating as an educated citizen. It is not enough. Okay. So everybody can benefit from technical education. Everybody can benefit from something that understands big data, technology, and the sciences. On the other hand, at least in the United States and to some extent elsewhere, if you are taking a technical undergraduate major, first, if you come in undeclared, it may be too late. I'm sorry, I'm getting ahead of myself. If you come in to most colleges, about a third of the students in most universities in the United States come in and don't know what they're doing. If they aren't undeclared in science by the time they declare, it's too late. Okay, so it takes them extra time, and they may still be behind because they've forgotten a lot that they had in their secondary education. Okay, and they have little idea that we were talking yesterday, I think, about the fact that women and minorities may have a misconception of exactly what is in computer science or in mathematics. And by the time they realize, hey, that's interesting, it's too late. Okay. On the other hand, students in technical majors, at least in the United States, have a lot of general education to make up, but also a huge technical demand, and may have very few extra credits to pick up other skills and perceptions and attitudes that they really need. Okay. Often the department in which they are in, or the advisors that they have, or the mentors, are very narrowly focused, unfortunately. They're in Najib's disciplinary straitjacket, to clean up his language a little. Right? And the students are focused on getting that first job. without seeing their longer-term skills involved. But it isn't just in the details. Long-term success in STEM, better responsibility, doing interesting work on projects, building community involves not just rote knowledge of facts and procedures and being able to program and code or carry out experiments, but you need to understand concepts and relationships, intellectual and social context, and at least some understanding of the philosophy of the discipline. You need to be open to new ideas, lifelong learning, being not only able but ready to learn, being ready to listen to other people and get ideas from other fields and export your own knowledge to other fields. Be ready to work with, learn from, and assist others. Being comfortable with teams as a leader, as an expert, as, if necessary, a documenter or a collaborator, and knowing how to communicate to different audiences. I've actually left out one here that I think is more important than most of these, being able to have fun with what you're doing. If you can't have fun, and you don't need the money, why are you doing it? Right? If your brain isn't working, why are you bothering? Okay, just to elaborate a little on the assumptions, and I'll skip over some of this, but what are some of the soft skills that I've just talked about? Communication. Okay, you need to be able to read, write, speak, listen, interact, and abstract. Okay, the technical, the popular, teaching. I don't care if you're a coder at some software firm. Unless you're the very bottom of the tree, and even then, you'll be teaching others, you'll be communicating with others, and if not, you're not long-lived. Right? You'll be learning from others. As I said, tailor communication to the audience. The things that work talking to your team are not the things that work talking to your manager. The things that work talking to your manager, your client is not interested in. The things that your team is interested in don't make up a good technical paper or presentation. And none of those work when you're coming and giving a talk at the local library. Everything has to be tailored, focused on who is listening. A lot of people here have learned this very well. I've been very impressed. A lot of people at other conferences I go to have not learned this very well. Okay, teamwork and shared leadership. Being able to brainstorm, plan at different levels from the enterprise to the division, to the project, or to the sort of project focus, to the project, to the team, to the individual subgroup that's writing code or carrying out an experiment. Okay, what we're talking about, software teams, obviously in sciences, lab teams, different groups. And you have to not only be able to work in teams, you have to be able to keep the team stable, keep it going, contribute what you can. Some people will be much better at that than others. Some of us alternate between being team builders and nuisances, but sometimes we can't help that. Role-based leadership, we just talked about that a couple of times. As I said, I'm hitting the same thing several times. Okay, lifelong learning. I'll let you read that one. Again, anyone who either can't read it or just would like to have this, please let me know. I'll be happy to give you the slides before they get posted. Probably mail them to you tonight or tomorrow morning. Arts, or at least aesthetics. good code, good proofs, good software projects, good applied mathematical models not only work, they're elegant. The style of elegance varies over the years a bit, but it turns out that the key to keeping software alive, keeping it maintainable, evolvable, reusable, is actually elegance, clarity, aesthetics. Which is just amazing. The key to developing new mathematics is starting with elegant old mathematics. Intellectual and social context, philosophy. The philosophy of mathematics, which is more concerned with the nature of what mathematics is. The philosophy of science, which is concerned with how science is done for the most part, or what science is. The difference between them. Logic, mathematics, computing, all the support you need for your own work. And again, in different areas, that may be other fields. Okay. Every modern field, except maybe for some pure formal sciences, nowadays seems to use statistics. It's going to become more and more important to understand the difference between frequentist models and Bayesian predictions, particularly since they're the key to a lot of data science and artificial intelligence. Ethics. I'm talking about its implications here for computer science, software engineering, data science, but we've heard enough about the implications for science as well, for nursing, even in the arts. And you also have ethics in relationships in your team, in your enterprise, with your client, with your suppliers, services. The social implications of your work. Professor Hashimoto was saying some very good things about that a few minutes ago. Every project includes what are the social implications, what are the ethical implications. Absolutely necessary in the long run. Security. Very, very important in data science and computing, but not unimportant elsewhere, including daily life. Why should we care? Everybody knows the students are always asking, why should we care? And the people who are funding you are always asking, why should we care? And even some of the faculty, after a few semesters of struggling through courses, will ask, why should I care? Basically, people want to do good. Most of us. Most of the time. Okay. Because security, privacy, intellectual property, confidentiality are important. Because we want to make sure that people have good experiences using our software, not just because we make money off of it, but because we're proud of what we're doing. Because there are professional codes of conduct and legal issues. Because not paying attention to all of these issues results in bad teamwork, bad software, bad testing, and bad relationships. Okay, finally, critical thinking. Again, requirements and risk. I've been punching that every time I get. Okay, modeling, integrating information, having multiple approaches, trying to match your tools, techniques, and processes to your problem, as opposed to putting everybody on Procrustes' bed. Agility where warranted, firm foundations where warranted. Incremental problem solving, incremental testing, debugging, revision, teamwork. Lots of stuff about teams. And the main point here is diversity is a big advantage. And analogies can come from surprising places and be very helpful. Analogies may come from cultures, they may come from other disciplines, they may come from your other experiences. They may come from the way a particular professor has presented something in your past. Okay, and people. Okay. The more diversity in general that you have, as long as your team can work together, the better your product will be. Doesn't mean that you go out to make the team diverse and you ignore the skills you need. That would. Diversity is an optimization criterion. The skills you need are a constraint. Okay. And focus on cultures. Okay. The more you know, the better you are. The more you think you know and you don't know, the worse you are. That's one of my problems. And intellectual growth and maturity. As you develop in your career, it's not just your own human life that should evolve. Your professional life and your professional understanding should evolve with it, and vice versa. We had a nice talk, I think it was Margit, about that emphasized the balance between family and work. You also have to have the balance between yourself as a professional and yourself as a human being. Okay. Conceptualization, lifelong learning again. Willingness to admit error. Okay, I have made mistakes. I will make mistakes. I am possibly making some right now. Okay. Perspective. And this I stole, okay, with modifications. As you grow, you have more responsibilities. You have responsibility for being very good at what you do. You have responsibility for listening more carefully, for speaking more clearly to different audiences, for eliciting information from different groups, from keep working with your team as a center, not necessarily as a leader, for building morale, for keeping your team together, for leading when you want, when you can, and for letting others lead when you shouldn't, or to help them develop. And I'd say, again, and being willing to admit error, being willing to admit you don't know. That you aren't just this, well, sage on the stage should not mean divinely omniscient and omnipotent. Right, even if you're going to take that model. Okay. Critical thinking, both from the discipline and outside the discipline. Natural science, I'm almost out of time. I haven't even gotten to the work yet, but this is important. Let me get to the work. Natural science is critical thinking, and I'm not saying everybody, okay, so professional science overlaps with this. I'm not saying everybody. On the other hand, so there are opportunities, even if you just had this little bit of extra. So we want to provide something that's a credential that helps other people transition into master's degrees, helps people who are technical fill in some of the soft skills they need. And on the other hand, we're not saying everybody needs to take a STEM graduate degree, or that everybody who takes a STEM certificate has to work in STEM, or even that everybody has to go to college. But we are saying we need more people who have the background, whether they wind up in STEM or not. So what we propose is a certificate that consists of, and these have to be mixed up because you get 4 courses basically, of communication for technical professionals, which will emphasize not just technical but other communication skills, problem analysis and solution, a survey of data science and its techniques, applications, perceptions, uses, social, ethical, and philosophical issues, and some of the foundations of tools. Okay, it can lead to a master's level study in STEM, can be an interdisciplinary program with a STEM content, can even be a standalone. Okay. Let me skip the transition. It's actually fairly straightforward. And again, as I said, I'll be happy to share the slides. Okay, how do you support the program? Recruitment, some institutional support, such as a room for people to study in and work in as teams. Okay, support for the faculty to take on an interdisciplinary perspective, and preferably some articulation with undergraduate programs. Okay, support, even if we can't provide money, at least counseling and maybe some support for dealing with pressures, trying to especially address first-generation students, minorities, women, students with disabilities, strong advising, tutoring, seminars, presentations by our students, program support from industry, from the people who have offered internships and a structure for getting them, and from our alumni, and recognition of accomplishments for faculty, for students, for teams. Okay. We need faculty to get credit for participating in here. This is a contribution toward your tenure or retention, not just something silly. Okay, we need to try to facilitate getting people into the program, possibly by getting them established early in the last couple of years of their undergraduate program. Give them a little bit of preparation. Okay, and one of the advantages is we can see if the student is really interested early. Okay, sorry. I know I have a couple of minutes left and I want to try to get at least through this. So before they try to start this, see if it's of any interest to them. Because they're coming from different disciplines, or they're coming and they don't have those skills. Okay, quickly, why did the students do it? We've talked about the benefits. There are some risks, taking a year maybe. And what if they don't finish it? Are they getting anything useful? I think so, but they may not. Faculty get to do some interesting things, get to learn some interesting things, get to work with some interesting people. But it depends on how much they already have an ongoing research program, ongoing student relationships, and it also depends on how much the university is willing to credit them for what they've done. University perspective, we've got more students. We've got interdisciplinary programs. Okay, and interactions, collaborations. Okay, university, the negative. Consortium, if we have the undergraduate institutions, we've got lots more possibilities for our students. Department, we can tell students they have more alternatives. We can offer interdisciplinary courses maybe. We can get people to take courses at other institutions with full faith, confidence that those courses work. From the economy, we get more knowledgeable workers. Okay. From society, we get a more diverse workforce. We get people who are in diverse communities with more opportunities, conversely. And we get more academic industrial interaction. Okay, inertia, and I will stop there. Okay, so I think there's a worthwhile program. We need people to consider it. We'd like to try to get this to work. Thank you.